My stream public. I think we're good. I think I'm streaming. I was just checking my phone to see. You are now live. Cool. I'll give people a couple minutes to funnel in, and then we can get started. Plan on wrapping up day 9. How's everybody doing? Probably get started in like 1 minute. Cool. Chat looks like it's working. If you're curious, I messaged something in the chat just to make sure it actually shows up. Because I've tried to stream before where everything looks good. Oh, thank you. Thank you for responding. Yeah, just as long as, like, I mean, I appreciate you sending a message. That's super nice. As long as I see that my message actually gets sent, then I know that, hey, stream's working. Because I've been in a situation where, like, I'll send a message and just it'll hang. And I'm like, oh, I've been talking to no one. So that's cool. All right. So, welcome back, everyone. It is a new day, and I am re-energized to tackle day 9, part 2. I streamed for almost 6 hours yesterday. We got part 1 done, and we could not get part 2 done. I kept running into stupid issues. I kept getting frustrated, and after a couple hours of just continuous coding, I was like, all right, brain's fried, can't do this. Here's what happened in between then and now, though. I jumped off, played some video games, did some late night cardio, and watched some TV. Everything was good. I was chilling, and then I was about to go to bed. It was like 1 a.m., and I was like, nope, I'm still frustrated about this problem. I want to get it, so I took out my laptop, and I started working on the Rust implementation. I didn't touch the bash code. I was like, okay, I know I can do this in Rust. I know exactly what the algorithm looks like. I don't know why I just don't finish this. I promise you, 10 minutes later, I had a working prototype. It just worked. Like, it literally just worked because I knew it would. I ran it against the example input. It looked like it gave the right answer. I ran it against the real input. It gave me an answer. I did not test it. I did not submit it. So it still could be wrong. But I'm going to go over what I did between then and now. So in day 9, we have this Rust directory that I started, and I did make some changes to the code, and I will show the code changes. So we have this file page struct. The idea is that for each block, we will make a file page. It will have the name of the block. This is the original index before things are moved. The size of the block, this is how much space it itself takes up. And the free after, this is how much free space it has after itself. So we have a vec of these, or a list of these, and that's how we can create all of the possible blocks on the disk. We have this helper function to print the pages. This just goes through and prints them the same way that the example page does. And we have a generate checksum method. So this just loops over all of the pages after we've sorted them and does all the work to generate the checksum. This is code we had working before, so there's nothing new here. We have the bash version, we have the awk version. They all work as expected. The new stuff is down here. So we loop over the inputs. We keep track of all the blocks we saw and all the free spaces we saw. And then we use those. We loop over both those at the same time to create a file page. And the file page, again, just has its name, size, and how much space comes after it. So now that we have the file page, this is no different than how we were doing in bash. We have two loops. We start from the end of the list. So we start at the right side of the list, which is all the way to the right. We have a loop here where we do while I is greater than 0. So we loop all the way to the beginning, but we don't actually touch the beginning because we're not going to move the pieces that are at the beginning of the list. And we name this loop. This is very important because we're going to break out of the loop or we're going to continue back to this loop. But let's move on. We print the pages for our own sake. We'll probably take this out when it comes time to do the real data. And then we figure out, okay, now that we have the piece that we're trying to move, I is the block that we're going to try and move. We start from the beginning. We go all the way up until the piece before I, and we check to see if that's a place that we can move I. So I is what we're moving, and J is where we're possibly moving it to. The way we determine this is we check, okay, J is where we want to move it to. How much free space does it have after it? Does J have enough room to squeeze I in? If it does not have enough room, we try again. We just continue the loop. But if we go here, then we do have enough room. So what I did last night is I wrote down the algorithm in like steps, and then I just implemented those steps. So imagine we have this. We have A, B, C is the place that we want to try and move it, and G is the piece that we're moving. So in this case, G is what we want to move to be in front of C. In order to do this algorithm, we have to remove G from the list, increase F free after by G point size and G plus free after. So what does that mean? F is the one that comes before G. This is the one that knew how much free space it had after. Now that we're removing G, we just inherited a bunch of free space. We have the whole length of G that's free and all the free space after G. So we have to increase F's free space by these two. Now we set the amount that comes after G to be what C had after it minus G's size. It's a little bit confusing, but G is going to move to be in front of C. So now C has less free space in front of it. In fact, C has 0 free space in front of it. G has whatever C had minus its original size, and that's what these two steps here do. And the final thing we do is we reinsert G into the array in front of C at the C plus 1 location. So I just do these steps here, and I literally broke them apart into all 5 steps. So first things first, we remove G. That's what we do. Then we increase F's free after by G dot size and G plus free after. It's so simple. Then we what do we do? We set the G free after to C free after. See, at this point, I might shut my brain off, and I just implemented what I wrote. I trusted my steps up here, and I just implemented them. And now that we were able to successfully move it, we continue to main. So we go back up to the main method. We didn't increment I, so we're going to keep trying to move something at the ith location because we moved that one piece out of it. So we made sure not to decrement I. But if we failed, if we didn't match anything, if we weren't able to move the block, try the next one to the left. And the way we do that is we just decrement I. That's all we do. And then we print the final page, we generate the checksum, we print the checksum. That's it. It's so easy. So let's go ahead and comment out, or actually no, let's leave those in. We will do a cargo run, and the input will be the example input. And there we go. Now this looks good because if we go here, here's what it should look like. Now there has filtered out moves that haven't made any difference, but their final string looks like this, 0921743. And if we look at the terminal, 092173. Like it's the same. We generate the same final string and we get the checksum of 2858. And of course, we go here and the checksum is 2858. Perfect. So let's go through and run this code against our real input. It's going to print a lot of stuff. So let's go ahead and just not have it print those pages. So it'll print nothing. It'll just print the checksum. And we'll run against the real input. It'll warn because that's unused. Cool. Now we have this big giant checksum. And this is where I got last night, and I haven't tested it because I want to save it for stream. So we will see. And that's still not the right answer. Cool. So all that work last night, and I still don't have the right answer. But that's fun. We get to work on it now. Here's the interesting thing. That answer is higher than it should be. Whereas before, our answer was lower than it should be. So we're doing something. Something's happening, but something's not happening correctly. So we're going to figure out why that's happening. So I'm at a little bit of a loss. I think our checksum logic is fine. It's got to be just our moving logic. We generated the correct checksum for the example input. So I think what we need to do is when we print the page, where's our print page function? Print page. We print the name, and the page name can have multiple digits. So let's put parentheses around it. And let's go ahead and print the final page. This is going to be a lot of data, but we're going to go ahead and print the final page. And this is what it looks like after we've compacted it. Oh boy. Cool. This is a nice way of seeing it. There's got to be a different way to visualize this. Let's come up with a different way of visualizing this. When we print it, we should print... I guess we could just print each block, couldn't we? Yeah, for page and page. We could literally just, instead of doing this, we could do this. We could just print page name colon size whatever. Yeah, page name size that free that. Okay, so now we can just do page.name page.size page.free after. Just make that a print line, and then we'll get rid of that. Cool, so this is what we end up with. This looks pretty compacted. Like, page 0 is here, page 999 made it all the way up here with a size of 3, and there's none of these have any free space after them. And as we get lower, we should have more things that have free space after them. Yep, okay, we're starting to see some free space ones and bigger free space. Yeah. Oh. We are doing something wrong. We could have like an off by 1 type of error somewhere. If we did, that'd be great because it would just be a small fix. There we go. So if that's the case, it should be just a small fix, and we might be able to do something. Let me think about this. While I is greater than 0, because we're not going to try and move the 0th piece. There'd be no reason to do that. We're going to try and move j to I minus 1. So if I is spot 5, we're going to try and move it to 4. This will only do 3. Let's just try this. I might just have an off by 1 error. Please just be that to be awesome. I don't know if that's the same number or not. Let's go ahead and try this. We were off by 1. We just had an off by 1 error. We weren't trying all the possible places. We got the right answer. Wow. Okay. Didn't take long to get the right answer here. All I needed was to take a break and come back for a new day. There's a life lesson in there somewhere. So we know the algorithm works. I had the right algorithm from the beginning. We just didn't have it expressed correctly in both Rust and Bash. Now that we are here, we're not done. We're going to go back and we're going to make this work in Bash. Like, we're not done. Like, yes, we have it working in Rust. So we can do git diff. Yeah, that's good enough. Works for me, lol. Oh, I'm not even sharing this. Yep. So we'll go ahead, we'll commit that, push that code up. Now that we have the Rust working one, we can go back and we can rewrite the Bash working one. And the way we do that is by opening both at the same time and just aligning them. Yo, what's up, Derek? Yeah, that's my goal. We got the Rust one working. We got the points. That's great. I got the points, so the puzzle's done. But for my own edification, I don't know what the right word is. For my own sake, I want to get the Bash one working. So we're going to do that. And how are we going to do that? Well, we're going to take a look at some of these algorithms that we have. While I is greater than 0. Oh boy, we were doing so much in the Bash one. This is crazy what we ended up coming up with. There are so many different ways to do this. We don't even want this. I equals len minus 1, I greater than equal to 0, I minus minus. Okay, this is the same thing. So we're doing the same thing here. Cool. And then for j equals 0, j less than I, j plus plus. I think that's what we have here. 0 dot dot I. So that'll bring us up to less than I. It won't actually give us exactly I. Cool. Now we have to check if cur size is less than or equal to free space. Oh yeah, we have this whole thing indented by 1. Let's do it differently. If the free space is less than cur size, so free space is less than cur size, we know that we're not big enough, so we have to just break on there. So we do a nice little early return type of thing. So now we can downgrade this, down indent it. All right, so now we can move. Let's go ahead and get that algorithm pulled over from the Rust code. This is the algorithm from the Rust code. Wow, that's not indented correctly. Cool. Let's just X out of that. Yeah, that's good enough. Okay. We have to remove G, but that doesn't quite work in Bash. Because the way we remove G is just by updating pointers. So we have to, oh boy, this is going to be difficult. Increase F free after by, so F equals what came before G. And G in this case is the thing that we are trying to move. So that is referenced by I. So F equals free blocks. Actually, let's just make our lives easier. G equals I. J equals C equals J. So now we have the variables that line up there. F equals G minus 1. Okay, so now we have variables we can reference there. We're getting close. F free is free blocks at F. And we are going to increase that. Okay, now we're going to increase this one. free blocks at F plus equal C free after minus G minus size. So C free after equals free blocks C, G size equals file size G. The nice thing is if we use these variables correctly, we don't really have to think. We just implement the algorithm. C minus free after minus G size. And there we go. Set G free after to C free after minus G size. Okay. So set G free after, set, so an equal sign, to C free after minus G size. Right, that makes sense. Set C free, I wrote fatter. C free after to 0. Cool. And then reinsert that G to that location. All right. So now we have to remove G, but we don't actually have to remove it. We just need to modify some pointers. So the next file of C will point to G, and the next file of G will point to D. And D is C plus 1. Yeah. It's confusing, but I think we have it. I think we have it. And now when we increment I, we need to break out and try the whole thing again. I haven't tested any of this, but we're gonna see. Well, that's wrong, because that should be 2858. Okay. Why is it trying to move 0? Oh my god, what is happening? What is happening? I have I greater than or equal to 0. Is that what I had in the Rust solution? I don't think I did. I had just greater than 0. Yeah, I don't think it'll make a difference, but we should make them exactly the same. Yeah, it wouldn't make a difference. Okay. Now we break out of that, we get down here, we go back up here, and we have I plus pluses, so we just try again. All right, can't move I to J. Echo can move I to J. Okay. We can move 9 to 0. That makes sense, so we do it. Trying to move 9 to 8. We can't. Oh, we're trying to move 9, which has the name 8, right? The last space of the array is name 8. Trying to move it to 0, can't. 1, can't. We literally can't move it anywhere, which makes sense. Now, this one we can move. We can move spot 8, which is 7s, to spot 2, which is after 1. That's correct. Maybe we just need a little final print all here. Okay, well, that is incorrect. Something isn't quite being moved how we expect it to, but that's okay. G is set to I. That's the thing we're trying to move. C is set to J. That's the thing we currently have. F is set to 1 below G. C free after is whatever free blocks has for C. G size is the file size of G. Okay, yeah, this all makes sense. And so number 2 is we set free after. Trying to make sure we're using the right variable everywhere. We are. Okay. So the first thing we're doing is the C free after is set to free block C. The G size, yeah, these are all right, is the file size of G. Echo C free after equals C free after G size. G size. C free after is how much free space it had, which is 3, and the size of the thing we're trying to move is 2. This is correct. This had 3 space after it, and it was moving size 3. Yeah, that makes sense. Well, let's throw some more debugging in. Yeah. Well, that doesn't make sense, does it? How did we end up with this? Somehow we lost track of the 8s and we kept track of the 7s. How do we do that? Just making sure all the variables we use on here are declared local. Total is not. I don't think we use it anywhere. Man, this is some of the ugliest code I've ever written. But we're onto something. It's when we try to move the 7s that break. We can move this to here. And we go through the process of moving it, but in that process of moving it, we've moved so many other things that we shouldn't have. So something got messed up here. Some of these indexes are just incorrect. Can move 7 to 7. Yeah, see, that's incorrect. It's correct that we can move it to the second thing, but that shouldn't be 7. That should be 8. So something's not being copied over. It could be this recreate all arrays logic. I'm not quite sure. But but something about the file names are not working as intended. Maybe it's my recreate all arrays function. Let's print the array there. So here are our file names. This makes sense. Here are our file names. 7 is duplicated. There's our problem. You used file names I in both cases when echo. Oh, did I? Oh man, it's totally possible that I did. Oh, you're totally right. Yep, I'm totally debugging something that's just fake. That's annoying. Thank you. I do still see something weird when I'm printing the array, though. I wonder if something wrong led me down the right path, but we shall see. Yeah, you're right. Can move spot 8, which is value number 7, to spot 2, which is value number 1. That is correct. And then 09123, 09123, and then after it should be 091723. And this last one becomes a 7 after the reconstruction of it when it should be an 8. Somehow this is becoming a 7 here when it should be an 8. 2, 3, 4, 5, 6, 7, and above here is 2, 3, 4, 5, 6, 7, 8. But we're not losing anything. Yeah, so in the reconstructing of all the arrays, something is not quite working. There's probably a pointer that I just haven't updated that needs to be moved. Let me think about this logic. In order to update the pointers, C is the thing that will now point to G, which means G now points to D. Oh, but that means F doesn't point to where G used to point to. Yeah, we need to do that first. We need F to point to H now in this example. So H in this example is just where G used to point to before it was set. I think that's okay. Because we're not using a vec which has indices like indices which Rust has. Okay, well we get a different answer now, but still wrong. This looks better. 0917234568. That looks better. That is how it should be. There should be 2 dots after the 8. Yeah, we updated to the however much we used to have free minus the... Wait, should it be minus? Oh, no, it shouldn't be minus. It shouldn't be minus. My actual documentation above says plus, and it should be plus. Yeah, that's what's happening here, of course. Well, we're still wrong. Well, we move the 7s into the right spot. That's clearly incorrect. Let's use this notation just so we can cut down on the number of errors. If we do it all in math, then it's kind of easier to read this way. 3167 just from doing that? Well, that's a little bit scary. Okay, this looks right. There's just extra free space that's not being... Every spot of free space has like one extra one. So some free space looks like it might be off by one. Increase free after of F by G size plus G free after. $2858. Oh my god, that's it. I just needed to actually read my own instructions. Okay, that's the correct checksum. Okay, wow. Let's go ahead and comment out some of this printing. This might just work. This might just work. So much commented out code. Yeah, let's not jinx it. You're right. How much will this print? Oh, that's so much. Yeah, for this bash solution, like... This is a lot of work. Like, Rust can do this in like half a second, but Bash is going to take some time because it's doing so much. I wonder if we can speed up some things. Yeah, I bet recreating all the arrays is stupidly slow, if I had to guess. Yeah, so much of it's just there, isn't it? Reconstructing the next file array. And all we're doing, let me think about this. All we're doing is resetting the next file to just be all of the numbers that come after it. I could probably optimize this. Let me think about how to optimize this. Because if the next file doesn't have anything set, we can just assume it's index plus 1. I think we can safely do that. We can do this. J equals I plus 1. Yeah, and if that's not set, then we can do J. I think we can do this. Or not, we just go into an infinite loop. No, we can't do that. Nah, we definitely can't do that. Because there's other logic that requires looking at the existing pointer. There's too much relying on certain pointers to be in certain places. It's just the construction of this. We need basically a list of every possible number. I'm going to do some testing. I think, can I do this? Instead of an array. Oh my god, I think you can. Yeah. Yeah, I can just do this. Do I have to fork out to sequence to do this? I might have to fork out to sequence to do this. No, I can be really gross. I can definitely be really gross about this. I can do this. And store that in an array, but then I still have the problem of these numbers. Maybe I'll just use the sequence command. I might just use the sequence command. We're in the 11th hour, so anything goes. So we can do next file equals this, which is sequence of 1 to len. If I do 1 to 5, I actually get 5. Okay, cool. 1 and including 5. I think this works, and this probably should work a lot faster. Yeah, that works a lot fast. Well, I don't know if it's a lot faster. I don't know how much faster that is to fork out to that, but let's see. Anecdotally, it seems a little faster, right? That J shouldn't mess up the other loop. I think I've made all the other things local where they are needed. Yeah, I think so. I think we just have to let this run. So what's it doing? It's looping the last spot of the array. Oh, so it's actually moving them every time. So the last spot of the array is always going to be 999, but the name of it's going to be different because that just means we were successfully able to defragment these things. Or successfully or not successfully. This just means that we've processed it. We may or may not have moved them. So technically speaking, this should get faster as it gets more done because there's just less places to check. Let me think about this. It'll get slower towards the middle and then way faster towards the end. We're going to let this run. We already have the solution working in Rust. We already got the puzzle complete. This is our answer. But now we're going to see if Bash can give us that exact same number. That is stupid. I'm going to take a quick, couple minute break, go grab something to drink or whatever. But I'm going to let this run. So This thing has made like no progress. Oh my god. Well, I think when that number on the right gets to 0, we're good. Well, enjoy this paint watching stream with me. I'm gonna go check my YouTube analytics. Does it have to run through all 10,000 of them to know your answer's good? I think so. It's starting from the right and moving things constantly to the left wherever there's room. There's probably ways I can optimize this, like instead of starting from the beginning every time, I could say like, oh, the first space didn't have room, so like we're not going to start there anymore. I could definitely speed this process up, but for now, just going to let it run. I totally just want to say that I think I do suck at programming because I'm sitting here watching this countdown very slowly. And then I realized, well, I didn't realize you told me the mic was muted. So not only that, I suck at streaming, man. This channel is going to be like Dave sucks at everything. I don't want to stop this, but I definitely can come up with ways of making it faster. There's nothing like watching a process move slowly to figure out ways of optimizing it. I know, it was just a joke. You're good. Oh man. I'm just fatigued after doing this problem for 6 hours yesterday not coming up with a solution, knocking it out in Rust like it was nothing, and getting the solution. Yeah, I had a couple hiccups here and there, but like the Rust solution was super easy. It ran in like a millisecond. And now I just gotta sit here and let this run, and it may not even be right. And the puzzle's already done. So even if this is wrong, I don't know. I don't know how much more work I should or could do on this. I guess what I can do is I can let that run on a different thing. Oh, this is way smaller text. This is probably unreadable on YouTube, isn't it? Yeah, it's way smaller. I won't subject you guys to this. I'm just kind of curious. It's weird that you got different answers for Rust and Bash. Well, the Rust answer was correct. So all that means is I'm getting the wrong answers with Bash. That's literally all it means. Yeah, we always start this at spot J. And there's no reason to check spot J if free is 0. Like if there's no free space here, then we can increment the number that we start this at. Yeah, no, Rust gave me the right answer. Rust, I absolutely got the right answer. I did it earlier in the stream, but you can see that the puzzle answer was this. Both parts of this puzzle are complete. I got 2 gold stars for it. So the Rust gave me the answer, and it gave me the answer in less than a second, with no multi-threading or anything. I mean, it's compiled language, just so much faster. But yeah, I'm trying to think. Like if I check J equals 0 and there's no free space there, I should increment where we start there. There's ways I could do it. CP part 2 to new, vim new. Start J equals 0. For J equals start J. If J equal start J plus 1 and free space equals 0, then start J plus plus. I think that's literally it. Yeah, I mean that read in from the example. I should let this run because it's halfway, but I should start up a new one and just get an idea of how much faster this is, if it's faster. This is one of those things that as it goes, it should get faster and faster. It seems like this one's already moving faster. It does seem faster, you're right. I know the text is smaller. If I try to make it bigger, it gets all out of whack. I gotta figure that out. But I think you're right. Like this one's like tick 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 tick. This is super scientific over here. Yeah, this one seems like it's just faster. How are my cores looking? No, I mean they're fine. They're both maxing out their individual CPU. Assuming my logic's written right, all I'm basically saying is instead of starting from all the way to the left to try and find free space, we can keep moving that pointer further right when we know there's no free space there. Like, hey, we've already compacted this. We can't do it anymore, so don't even bother looking there. That's what that logic does, and we will race them, and we will see which one finishes. Okay. I see some moving a little bit faster here. They're probably finding places they can jump in there early. I should have printed the start, Jay. I didn't even think about that. Yo, what's up, Gorv? How you doing? Oh yeah, look at this. The names are starting to get interspersed. That's cool to see. Yeah, we're moving down now. Wow, we're actually making progress in the loop. About halfway in, we're actually starting to make some progress. Look at that. Speeding up. Wow, how incredible. By contrast, this thing's still moving a little bit slowly. Although I think this one could pick up in the end. So we'll see. How about you? I'm hanging in there. I'm good. I streamed for about 6 hours yesterday and couldn't get the solution to part 2 of this problem, and it was very frustrating. But then I jumped back on today. I got frustrated at 1 a.m. and went through and figured it out in Rust and got a somewhat working implementation in like 10 minutes. It's way easier to do this in Rust. And I ended up solving this puzzle. So this puzzle is solved. It's complete. I did it in Rust. I have the right answer. I know the algorithm. I'm just trying to make sure I can get it working in Bash now. Okay, it's already down to 9,000. This thing's cranking away. Look at that. Definitely speeding up now, which is good. That's what I thought would happen. And that's because now that it's going, the pointer on the right-hand side is getting smaller, so it has less things to check, so it should get faster and faster. This one should get way faster because it'll have less things to check on the left and the right, but we have to let it get there because this one's going to start cooking it. Do you show it being done in Rust? Yes. At the beginning of this VOD, when I first start streaming, I go through and I explain exactly how the Rust algorithm works. It had a couple of issues, some off by one errors, little things I debugged live, but then I got the right answer with it. So yes, I do show that in this VOD. Cool, so this one's still going slowly. Oh man, excuse me. I drank way too much soda. Oh yeah, this thing's cooking over here. Look at this. I mean, it'll cook for it to finally give us the wrong answer, right? Yeah, this thing's dogging it over here. It's quite cool to see that you're able to code fast without using LSP. Yeah, I mean, thank you for that. I don't know. I guess I grew up in the era where that just wasn't a thing. So when people started using it, I just found it distracting. So like, I meet coworkers, I would say younger than me, but even some people older than me, like they have all this stuff, like their editor is flashing them nonstop. It feels like I'm on a website with pop-ups. I'm like, how do you code like this? I just started coding and some like gutter comes in from the left-hand side to give me some information. It's like, look how much information I can see where it is in Git and where this is and what this is. I was like, I don't want that information. Like, I want to just go from brain to text. Second one slowed down, not gonna lie. No, I agree. I think it did. Maybe we're just used to this one cranking over here, but this one, like, it does seem slower. I'm with you on that one. But we'll see. When it gets down to like 5,000-ish, it should pick up, and it should be very noticeable. Of course, this optimization doesn't work if there's like, you know, one thing of free space at the beginning and none of the items can fit into one. I mean, the optimization just kind of stops there, so who knows how optimizable the input is. Oh yeah, look at this. Once that left number hits 0, we're done. And the calculating the checksum, I'm pretty sure, is pretty fast. Exactly, yeah. The first one definitely had an unfair advantage. Yeah, this isn't too bad. This isn't too bad at all. This thing wants to catch up. Cool, we're almost at like seconds if you think about it. Like 39, 38, 37. A little bit longer than seconds, but getting faster with each iteration down. Cool. This looks like the kind of output you'd have on a TV when like there's like a scene where someone's hacking on a computer. Like this is the kind of output you would see. Oh yeah, there's no way the one on the right's catching up. I'm gonna let it run and we'll see how fast it can go, but yeah, it's not catching up. Now this thing totally could just spit out the wrong answer, so I'm mentally prepared for that. Moment of truth. 62868787. 628731. No, it's wrong. 6287. This one is slightly higher. Yeah. The checksum here is just slightly higher. So we just slightly got the wrong answer. That's okay. We tried. We'll let this one over here finish. Oh yeah, there's no way it's catching up. I am back at it. I have it working in Rust. I got the right answer. So I do know what the right answer is in Rust, which is fine. Now I'm stubborn. I'm just absolutely stubborn, and I want this bash one to work, even though the code is so garbage. Honestly, I should rewrite it. Truly, honestly, I should rewrite this code. Yeah. Calculate the checksum with all just in case. I could do something like that. It shouldn't be overflow. I mean, this number should fit comfortably in a 64-bit number, and Bash can do 64-bit numbers. And it looks so similar to what the right answer is. Like, it literally is so close to the right answer. Here's what I'll do. We'll take, this is the answer I got. And the right answer I'll grab from the website, copy and paste from the website, and we'll get the difference between them. That's not that big of a difference for how long this number is. Being off by that much when the number is here. Like, they're very similar, as you can see. How long does it take to run in Rust? You ready for this? Are you ready for this? You're not ready for this. You're absolutely not ready for this. Cargo run, dash Q. Oh, we'll do release. Example input. There we go. Now we'll do the real input. It might print a lot. Let me get rid of the prints just because the prints will slow it down. Yeah, this is the only thing. I don't want to slow it down with the prints, so it'll just print the checksum. Here's what we'll do. We will time it on the real input. Actually, no, this is an unfair. Let's do it correctly. Cargo build release. We'll build the release binary, and then we can run the release binary directly. And this way there's no compilation steps. Like, this will just be the raw program running. Real input. Time it. That's how long the Rust version takes. 0.04 seconds. It takes 41 milliseconds. And probably a lot of that is actually like fork and exec. So that's the Rust version. I mean, like, what do I say, man? That's the Rust version, and it gives the right answer. So, like, oh, man. Here's the thing. I like these puzzles, and I'm having a ton of fun with them, and I'm going to keep trying to do them as long as I can in Bash. But if it ends up becoming too difficult, I still want to get the puzzles done, so I probably will switch to just using Rust. I'm comfortable in the language. We have, you know, better structured data. Because the Rust code even just looks nicer. Like, I was able to make a file page struct that keeps track of the name of the file, the size of it, and how much free space it has after. And then when you have that information, it's super easy to just write, you know, very C-style looking code to generate the checksum. And it's very easy to write code, like to write this algorithm out with a list and then just do each step of the algorithm. Like, Rust is just great. Yeah, structured data is like what I need. Like it's just the right way to do it. Ah, man, but it does stink that this just doesn't seem to be right. There's some logic here that is just incorrect, and I just don't know what it is. So it's unfortunate. I like Rust. I would recommend Rust if you're between Rust and Go. I'm a little biased. I mean, I just love Rust, so there's that. Where do I use iFreeSpace? I don't use iFreeSpace. Where do I use current size? That's the current size of the thing we're moving, and that's how much free space we had available. Cool. We start at the beginning. We go all the way up until the thing we're trying to move, and then we see if the free space is less than the current size, we don't have enough to move, so we just try again. If we can move it, then we have to go through this whole song and dance of moving it. I mean, it could be my logic to generate the checksum that's wrong, but I doubt it. Calculate checksum. Local I, J, accum, len, and total. Okay, so we have the length of everything. We loop over every single element in that array. We get the name, we get the file size, we get the free blocks. So this is the index. How do I generate the checksum? Let me look at this. Total. Okay, so total is the index of the thing. Okay. Yep, so it's at spot 0. Then we increment it. Now it's at spot 1. Increment it. Yeah, this all makes sense. And if it's a free space, we just increment the total index. We don't actually do any work. I can't see anything wrong with that logic. Oh, look, it's starting to go a little bit faster on this thing now. That's cool. What other languages would you be able to solve these puzzles in a reasonable time? Rust would be the easiest one. I could do JavaScript, but it'd be hacky JavaScript that looks like someone wrote it 10 years ago, which is me. I'm that someone. I would say Rust, C, JavaScript. After Rust, it'd be C. I would prefer to write it in C. Just looking through my code, make sure I have everything right. Generate checksum. I basically do the exact same process here. Like this is identical. Oh, I could just increment the index by that number instead of doing it in a for loop. It'd probably be a lot faster, but generating the checksum is not the slow part of the code. Okay, look, this one finished over here. So this one finished a lot faster once it got cooking. Yeah, it did. But let me check the number. It gave us the wrong number. Yeah. It's just slightly below what it needs to be. Like that's what's happening here. So it's just slightly below what needs to happen there, which is sad. Let me do this. Let me grab the logic out of new that I did. Oh, I'm editing new, am I? Yeah, edit part 2. Okay, so this will start moving. Okay, cool. So now start J gets incremented when there's less things for it to check. That's cool. That's a cool little thing. Those kind of problems, Python should be fairly fast if you also account for more easy writing. I don't know Python. So like, I mean, maybe you guys can do it. I don't know Python. Like I wouldn't feel comfortable in that language. I don't know it at all. Can you check the diff after defragmentation between Rust, Bash to debug it? I think that's what I'm going to have to do. I'll have to come up with some sort of way to write down what it looks like. And I think I already have like a format that makes sense. Let me check my Rust one, because I think my Rust one had a good format. What am I doing? Yeah, I think for the format, I print out... Yeah, so at the end, I would print out the page, the size, and the free. So if I run this, do a cargo run -q, example input. So at the end, it will print, okay, the page with the name of 0 has a size 2 and a free of 0. This is what it looks like after defragmentation. So I could just write that to a file, like output.txt. So much faster than Bash. Oh my god. So yeah, now if we look at this, we can see like what it should look like after everything's done. So with that in place, I can make the Bash version print that exact same output. We can put a print all into final.txt. We'll also just do a print all here. Wait, why don't we just do this? Hey, look at that. Unix. That will do both. It'll print it to the screen and write it to the file. So now we will do a print all. And the way we do a print all is we loop over everything we have, name size free, and we just... I'm basically doing what we did above, but we'll just echo the exact same output. So page number : size free. Is this the output? No comma. Close, but no comma. Cool. Then we don't need this. Okay. So this just generates the exact same output. Nice. And then the trying to move, we'll just make that go to standard error so we can look at it in the output, but it won't get put there for us. Okay, cool. So that output should look exactly the same. Yeah, size 2, free 0, 1, about 2. Cool, 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 cool. You can easily take the Rust output and make the defrag string you have saved and compare the files. That's basically what I'm going to do. I can't make the defrag string that they show in the example, if this is what you're talking about, like here, because this example falls apart once your digits go above 9. I would need some sort of symbol to represent them or put parentheses around them. So that's why I'm just going to print out what the final list looks like, basically the linked list. So yeah, we got part 2 printing that. Nice. So we can time this, and we can do real input, and then this should just write to that file, I think, right? Final.txt. Yeah. Cool. So yeah. Missing equal sign. Where? Howdy again. Do you prefer Vim or Nano? What do you think? What do you think when you watch my stream? What do you think I prefer? Oh, equal sign in the output. You're right. No, wait, am I? No. No, there's equal signs there. Am I crazy? Yeah, these outputs look the same to me. Actually, we can just find out. Final diff and Rust output. Oh, right. The Rust the Rust output is the full big thing. The Rust output. there's no equal sign in here. Okay, that's what you were saying. Size free. Okay, I got it. I could have edited it out later, which is not the end of the world, but for the sake of doing things right. Part 2. Read in from example input. Should generate that. When I cat final text, it looks like that. When I cat the Rust part 2 output.txt, I get that. Very similar. Cool. Time part 2. Read in from real input. And that's all we should have to do. And it will just run. And it will take a long time. But that start J will move up. We'll at least get to see that, which is pretty neat. Let's see. Vim. Yeah, of course. I love Vim. Vim is great. I prefer Vim too. Nano sucks. I wouldn't say Nano sucks. Nano's a great editor. It's just Vim is more powerful. Vim is what I would use to... If I'm going to sit in an editor, I want something that has power behind it. But like Nano's a great program. I don't say it sucks. I just wouldn't really, like, I don't know. Comparing them is kind of weird. I'll make jokes about it, but yeah. Look at that. It's so cool to watch the pointers move. So the pointer to the left is always 9999 until we start getting lower. And the pointer on the right, which points to the left, is 274 now. That's cool. It's cool to watch this. It is disheartening to know the answer will be wrong, but we at least can compare our final notes and maybe glean some information out of it. That is a big solid maybe there. Man, so this is going to take some time. Also, thank you everyone for tuning in, and thank you for tuning in yesterday. I streamed for a long time yesterday, and it was crazy. Like, when I woke up this morning, the amount of subscribers I had on YouTube was way higher. So I don't know if people subscribe when they're watching the stream or what, but I had like my biggest day of subscriber growth, so that was pretty cool. So yeah, appreciate it, everyone. Let's hope the data analysis bears fruit. That's what we're hoping for. This will print out a nice file that we can check. Interesting that start J always seems to grow like by multiples. All right, I'm gonna step away for a minute or two. This mute button's going to take 8 years to run. It's the worst thing, too. It's like there's a cost to trying to test this stuff. It'd be nice to have like a minimum viable puzzle, something that like the example works, the real data doesn't, something in between that. But I'd have to come up with that and test it and see. So basically coming up with examples that break my program and work on the real one. And it would just be maybe throwing things at the wall and trying to see what sticks. So hopefully this will give us some insight. Maybe you can check it before it's fully finished. Could be that some mistake has happened already. Yeah, agreed. Actually, what I could do, I could have it so every single iteration, we could have it just write out a file. So like, 1.txt, 2.txt, 3.txt. We could have rust 1.txt and bash 1.txt. Rust 2.txt, bash 2.txt. And then we can go until we find the differences. And once we find the differences, we can kind of get an idea of what's happening. That might be the way to do it. Because you're right. I mean, an error probably, if there's some sort of cascading error, it's probably already happened. So, yep. How big is that font? Is it like roughly the same size font? Probably. Cool. So now we have two terminals, both with good size fonts. We'll let that run, and then we will do and then we will mess with the Rust one while we're doing it, because I think we can like write a file. Oh, a super chat. Oh my god, thank you so much. Here's a few for the smaller channels. Yo, appreciate it. Thank you. Who cares? I guess the answer is you care. But yo, no, appreciate it. That's awesome. Is Emacs still being widely used? I'd never heard it mentioned anymore. I think people still use it. I hear it mentioned every so often, but yeah, I don't know. It'll way slower to write a file for each iteration. Nah, file system's generally pretty fast. Maybe for Bash it'll be slower. It'll be very slow to have to represent all the data as some sort of string, but like writing the file should be fast, especially in Rust. Like file systems on an NVMe drive, like it's gonna be fast. Let's see if we can do this. I think I have to make a terminal profile. You're right. I also have notes for myself to make like a script I can run that just opens up all my windows and puts them at the right size, because there's so much like finicky nonsense here. Instead of print pages, we'll just make this as like create serialize pages. And this will return a string. And then we can just do this, make a mutable string here, and then we can write this into the string. Format this with a new line, and then we can do s.push stir. Line. And then we can just return S here. So now this function generates a string instead. So instead of print pages, we'll just change this to serialize pages. Yeah. Done.text, and then we can do what is it, fs write the name of the file and the data we want to write to it. And we can just do the same up here. Instead of printing them, we will just write them out. And we'll write them out to, we'll just keep a global counter. And then we'll just increment the counter here. So serialize the pages, create a file name for this. The file name will be Rust number. There we go. So now this will write out a whole bunch of text files into the current directory. So let's go ahead and just run this, and we'll run it with the real input, and I will show you guys how fast it is to write out these actual files. You ready for this? It's gonna have to compile, so that might be a little bit of why it's slow. I shouldn't have ran it with the -Q. We could have actually seen it like compile. Okay, I'll be honest, I thought it'd be faster than this. Okay, yeah, it's done. I mean, I don't know how long that took. I should have put timing in front of it. Probably like a couple seconds. But yeah, there we go. So now if we do rust 0.text, that's what it looked like at first. So we could do a diff rust 0.text to rust 1.text, and this will show us what the first move looked like. So in order to turn rust 0 into rust 2, we'd have to get rid of page 0 having size 5 and free 4. Now page 0 has size 5 but free 0. So now it has 0 free spaces, and the reason for that is because we moved 999 into that spot, and it has a size of 3, and it has a free of 1 because 3 plus 1 equals the original 4 up here. Cool. And because of that, 999 now had to move out of the way, and 998 had its free space increased by whatever the size of 999 was. This all makes sense. This all works. I can do color diff instead. Color diff's just like a little wrapper I wrote around diff that just uses awk to add coloring. Makes it way easier to see. I don't know why I didn't just use that to begin with. Let's see. By the way, I understand you might think / know your colors are perfect. I don't think that or know that. But I think they are a bit too dark to be clear and readable on a smaller screen. Oh, I don't doubt that, yeah. In other words, I think your videos would benefit from some high contrast color scheme. I agree with that, 100%. And I've done work to try and do that. In my edited videos, I actually go through and bump up the contrast of them so it becomes more readable. On the live stream, they're not as good. I want to do that in my streaming software. So in my streaming software, I can add a color filter, and I've been trying to bump up the contrast there. The problem is the streaming software on Mac seems to have a bug. So let's see if you guys can see this actually. I'll go to my terminal. This is so stupid. So I have to make open an issue with OBS and figure out what's going on. I can open up a window in my streaming software to edit my terminal. I'm going to add an effect on it. We're going to apply I believe it's color key. Is that what it is? Let me look real quick. Sharpen, scroll, aspect, render, luma key. Nope. Crop pad, color key, color correction. I'm going to add a color correction filter. Watch what happens. The moment I add the filter, this is what happens. The filter is supposed to be null. It's not supposed to have any effect, but the moment I add the filter, it just becomes unreadable. Hopefully it's streaming to you this way. Hopefully it's not just on my end. I don't know what the stream looks like, but did the colors become completely like unreadable? Like the colors just don't show up at all? Because that's what happens, and it's not supposed to happen. So somewhere at some point there might be some HDR thing going on. I don't know what the answer is, but I cannot bump the contrast, unfortunately. So I'd have to do it through my terminal, and I can't quite get good colors that work this way. I'd rather just do it in post-processing. Yeah, red and green. Yeah, it's unreadable. Yeah, it sucks. Because on my end it looks that way too. And every video I watch online shows the color correction in OBS is not supposed to do this. So, and it doesn't do it. If I put it on my webcam, it doesn't do it at all. It's only on the Mac desktop application sharing that this happens. So I think there's some BS going on here. I'll default it. This will wipe it all out and reset the defaults. Nothing happens. Now I'm going to remove the color correction, and it is removed. So now it should go back to being readable. So yes, I agree. I want my stuff to be higher contrast. OBS won't let me do it currently, but hopefully I can come up with some sort of solution that fixes it. So I do in post when these videos get uploaded as their own individual videos, I do go through and correct those. So at least you have that. At least they look a little bit better when they're done. Yeah. You're dope, Dave Eddie. Yo, what's up? Appreciate it. Oh, look at this. Look how that number approaches the start J. We're getting close to the end here. We should just break out when that left number collides with that right number. Hey, we did. Cool. Oh, I like how nothing got printed here. That's really cool. Nothing got printed here. I wonder if that's part of the bug. I mean, it shouldn't be. We could just be missing one thing at the end. It's like 14 minutes to run. Whoa. It takes forever. And this is what the final thing looks like. Let me go look into this terminal, and we're going to look at the final thing. I think I called it done.txt. Let's go to the bottom of done.txt. 5452, size 9, free, 42929. 5452, size 9, free, 42929. 33, 3, 23, 20, 85. What if this is right? All right. This is less than ideal, everyone. This is less than ideal what I'm going to do. But I'm going to do it, and you're going to watch me. You are all complicit in this. What y'all know about copy and paste? Can I just do this? Oh, yeah. That's way easier. Oh, my God. We're getting there. We're getting here. Yeah, the fact that something is not printed at the bottom. Vim done.txt. Cool. We're going to let that paste in there. Seriously, why not just toggle on some stream settings / color in your terminal until the OBS issue gets fixed, which could take a decade? You're right that it could take a decade. Here's why I don't do that. Because the colors look a little bit washed out and the contrast looks low on the stream. But on my display, what I see directly in front of me is vibrant as heck, and I hate it. It's actually too vibrant. I do not like it. So the color difference there, what I try to do in post is make it look like what I see. So I couldn't stand it if I increase the saturation on this. It already is so bright that it annoys me. That's the only reason why I don't do it. Since it was mentioned, what kind of theme is that? Is it me or the foreground colors seem like the default light theme? It's the default theme. I just use the default Vim theme. This is just the default Vim theme, but it's for light backgrounds. I just like the way it looks on black backgrounds, but I have changed one thing, and that's the color of the comments. I've made the color of the comments brighter. So in my vimrc, right here, I set background equal to light, so it just thinks, because background equal to dark, looks like this. And maybe you guys like it, but I don't like that. I think this is ugly. I like the way these colors look. But then you have this comment color. Look how dark these comments are. So I do HI comment C term FG 63. 63 is just a 256 color code, and you can just kind of brighten it up that way. These you could put any color here. I mean, that kind of looks nice, doesn't it? I just kind of did that and looks nice. Wow. Tab stop 8 text whether yeah 100% hard tabs 8 spaces to display a tab. No greater than 80 columns in your code. That's what I believe in. So yeah, okay. So this is our bash version of done. So in order to turn our bash version of done into our Rust version of done, where are we? We're in Rust. Okay. In order to turn our bash version of Rust, bash version of this, whatever. In order to turn the bash version into the Rust version, the wrong into the right, we would need to do this. Okay. Okay. That's the only difference? So when bash is said and done, when Rust is said and done, the only difference is this one line. This one line. And that makes sense. That makes sense. The bash version, look at this. What is this? The bash version lost track of a block. At some point, it lost track of a single block. The block it lost track of was 4867. What happened to 4867? Where is 4867? Oh, it's like it's towards the bottom, but it's not like it's not close to the bottom or close to the top. It's just in its own little world. We have lost track of 4867, a size 9 thing. So now all of our checksum calculations are going to be wrong. Wait, did I say 4867? Did I search for 5867? I searched for 5867. 94. Okay. We've lost track of 6 bytes. We've lost track of them. We have lost them. Where have they gone? When do we attempt to move 4867? I'm guessing that's towards the end of the thing, right? Well, we have the Rust version. The Rust version is very fast. So let's go ahead. And the Rust version even uses the slower algorithm, which is funny. Let's go ahead and print that out. I want to know when it tries to do this. We're not going to write that file out. We're not going to bother serializing it. It's just going to be slow. Okay, when do we try to move 4867? Okay. So now we will. You search 4857. Did I search it wrong a second time? Did I really do that? I probably did. What do I keep saying? 4867? Okay, wow. 4867. 4867. It is 94,000. 4867. Size 2 with free 2. That's where it shows up. And when I go into the bash version, it's just not there. So we need to figure out when does 46 whatever, I don't care. 4867. When does that one? Yeah, 4867, size 2, free 2. When does that one get tried? We'll find out by doing a cargo run of the real input. Okay, try to move it twice. It's like towards the middle. It's just like some random time in the middle we try to move it. What is special about that one? How are we losing track of it? How do we just lose a variable at some point? Yeah, and somehow when we went to print the bash one, remember, now it's gonna be all messed up now. But yeah, it printed this. So like something broke here. Why did it try to move it twice? I agree. Why did it? Should it? Is that normal? Let me do a test here. I'm going to run it and pipe it to sort. Then we're going to pipe it to unique -c and then sort -n. It looks like it tries to move a bunch of them twice. No, I think it's fine to move something twice. I think it's okay to move something twice. Because this is not the index, this is the name of the block. So you might be able to move the block to the left and then your pointer goes down, 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 down. And then when it encounters it again, it will try to move it again. That's normal. Even the example, I think, shows something being... No. Yeah, I think you can try to move it twice. It just shouldn't work. If you've already moved it once, there shouldn't be anywhere else that's valid for it to move. I just don't have a check for that. Like, it will try to move it twice. It just will fail. Dump every index in Rust when it's 4867. Yeah, we really got to do something. Like, what is happening here? It'll be at the best position the first time, but the loop will go down and see it and be like, oh, hey, we should try and move you, but it should fail. There should be nowhere to move it to. I could keep track of which ones I've moved and just ignore them. That's totally a possibility. I mean, that'd be a way to speed up the Rust implementation, and even the Bash one. But, like, I don't do that. So it will try to move it a second time. It's already in the best position. So we just don't keep track of what is in the best position. We could. It might be faster. Let me go ahead and just add that to Bash. Because what we could do here is we could do something like declare -a has moved. And then once we know that we've moved something, we could say, what is the thing we're moving is G. So we can do has moved G, which is the name of the thing that we're moving. We need the name. Equals 1. Let's just do this. Yeah, it has moved equals 1. And then we can do a quick little check up here, like, oh no, J is the thing that we're trying to see if it should move to. So the thing we're trying to move is not J, it's I. No. Yeah, once we've moved it, whether we've moved it successfully or not, like, we don't need to keep reprocessing it. So I don't even know if we need to store this here. We need to just say, like, hey, like, once we're processing this, we could basically just store it here, whether we're successful or not. Like, if we're successful, it's in the best position. If we're not successful, it's in the best position, and no position's going to open up for it all of a sudden. I think we can do that. I don't know how much faster that'll be. Can't tell if that's faster or not. Let's go back. Let that run. Let's go back to the Rust implementation. Yeah, because the freed space only appears behind the index we moved. Yeah, exactly. Somehow we are losing 4867. So about 5,300 moves in, we try to move 4867. And we don't try to. I mean, we move it. It moves successfully. Maybe the J index catches up to I. Yeah, it's totally true. We got to dump everything here. If we are at 4867, we need, we just need a full dump of everything. Counter equals this. I equals this. I is equal to 9421. That happens early then. Yeah, that's relatively early that it's 9421 because it starts at 10,000. No. The counter goes up, doesn't it? So about 9,000 moves in, we encounter that. Weird. Oh. It's not Vim highlighting, it's my terminal highlighting it. That's annoying. How's this thing doing? Does seem to be going a little bit faster over here, I will say that. Little optimizations on the bash one are nice. Yeah, something's just being lost in the bash one. Alright, so which one did I... Let's do the Rust one. We'll do the Rust one. We'll find the counter equals this. This happens at 5391 and 5390. So, 5390 is where it hasn't happened yet. So if we cat 5390, where are we? Cat Rust 5390, we're here. So what happened between these two steps? So what happened here is we moved 4867. We haven't moved it. We've just moved the free space. Oh, okay. Okay, so what happens here is 4867 and 4866 don't move, or 4867 doesn't move. It just gets pushed against 4866. So there's a gap, a 2-space gap between them, and they just slam together. And then we try to move it again between here and here. And this is where we try to move it again. And nothing was able to be moved because it's already in the best position. Yeah. I'm looking at the example input. There's no... Okay. We're done here. We're going to make a new example input. I know, I think I have an example input that could make this work. Oh, God. I'm going to write out what I want. I want this. I want that. That's what I want my example input to be. So 22 will just get shoved up against 11, but it won't actually have to swap places with anything. That's what I want. So I need to represent that. And I have to remember how this thing works. So spot 0 will have 2, then there'll be 2 free spaces, then there'll be 2 of this. That's it. That's all I want. Literally 2, 2, 2. So if we do part 2 and read in from new example. Okay. Okay. And if we read in, if we use the Rust example. Okay. This is our problem. We've isolated it. This is the problem. Literally the problem is if the decompressed data looks like this, then we don't actually move. We're not moving 1 over. We're just moving the free space. Rust handles this because I wrote the algorithm beautifully because I'm a master programmer and there isn't a programmer better than me alive. The Bash one doesn't handle this because Bash is the best programming language that's ever been written, and you will never hear me talk poorly about it. Cool. We have... Oh my god. Thank you everyone for all your suggestions. We have a way of exercising this bad behavior now. So, 137 has a bad... Wait, is it just the has moved part? Oh. Is it just my new logic? If it's just my new logic, then... Oh, no, it's okay. Because that means we're failing to extract the file names. That's okay then. That's okay. Yes, the name is empty there. Why is the name empty there? The length of the array... What is len here? The length of the array is 2. So I equals length minus 1. So I is set to 1. While I is greater than 0, which it is, we're just doing the first iteration of this. I have to figure out what's going on here. Here, when I is set to 1, and that's fun. Trying to move 1 to 1. That's good. Like, we're trying to move it to itself, and there is free space for it. But then we somehow end up here again, when we shouldn't be there, with an I value that's out of place. Huh. Reading data. I is 2. Oh no, the len is 2. Then we're here. So we start at 1. Here again with 1. But this time it's a bad array subscript. Why is it a bad array subscript? You're right. I could do this syntax. It shouldn't matter for an index arrays. Bad array subscript on has moved. Yeah, because somehow name is coming out empty. You know what we'll do? We'll print the array of file names here. Alright, we've lost a file name in the process. Yeah. We've lost a file name in the process. We're not keeping track of it properly. Wow. Glad I threw this in. This is exposing some logic that's breaking here. So I'm going to guess that it's in recreate all arrays. God, I hate this code. I'll be so happy when I'm done with it. Before. Looks like I've already done this logic before. After. Yeah, okay. So it's in that logic that we are removing that. How is that happening? The len is set to 2. The len is set to 2, so we should be adding this in twice. Although this is throwing me off. We should never encounter this problem. This might have been masking a bug. Um, 0 points a null and null points a null. Somehow we're getting null written as... Yeah, that's not right. Null points to null. I don't know what's happening there. Or Our pointers are wrong. And I think it's because we're trying to do a swap here. Only swap if needed? Ugh. I don't want to complicate this logic too much, but like, if... Let's see. Where's the thing we're trying to move? Yeah. If G minus C is 1, then we know they're right next to each other, so we don't need to move them. So if G minus C is greater than 1, then we need to move them. Well, this looked way better. We got a checksum of 5. What do we get with the Rust implementation? We get a checksum of 5. No way. What do we get? We get the example input. We get 2858. I think this will work. I think this will work. It's a lot of output it prints. Let's go ahead and just clean up some of that output, because I think that's a lot. Yeah. Wow, yeah, we weren't handling that one specific scenario, but we were able to create a test that can simulate that specific scenario. How many times am I just gonna echo here? I like the trying to move. That's useful. We'll leave that in place. Okay. Okay. Wow, so there was just one scenario that wasn't working. I enjoy this live because you suddenly look like a mortal debugging code like the rest of us. I am. Yeah, don't let me fool you, man. I suck at programming too. But it's fun. Debugging code is like fun. Frustrating. Can be incredibly frustrating, but it can be rewarding when you get it. So yeah, I think we just let this run. And that will handle that one scenario that apparently only happens once. How crazy. How absolutely crazy that that is the case. So this, what, takes 10, 15 minutes? All right, I'm going to step away for a bit. Probably a minute or two. I'll be back. All right, what's up, gamers? I'm back. How long does it take the Rust version to output an answer? 40 milliseconds. Yep, 100%. It's crazy fast. Here, I can show you. I can show you over here. Where are we? Cargo, run. Right, here's what we'll do. We'll build it in... let me do some testing first. Example input looks like that. Trying to move, it prints out all that stuff. And then the real input... We'll print out a whole bunch of trying to moves. That will slow it down, but you get an idea of how fast it is. If I comment out this, and we just print the checksum, or at least those things and the checksum, we can see that it's like crazy fast. If we throw in a dash release, like forget about it. Like, that's how fast it works. It's so fast. It's stupid. So like I said, if I get frustrated with these puzzles going forward, I'll probably ditch Bash sooner and just go straight to the Rust solution. It's the way to do it. Opinion on PowerShell? I've used it once in my life. I have no real opinion on it. Yeah, I couldn't tell you anything about PowerShell. I know some people who use it and love it. I've tried to convince some people to make you suck at PowerShell. But yeah, no, I don't really have many opinions on it. I don't have to use it much, luckily. Oh, my phone's dead? That's cool. Well, the nice thing is this version seems to be going pretty fast. Can't complain with the speed of it. The Home Depot requests my feedback. Nah, I'm good, bro. Oh man, I wish this thing just, moved a little bit faster. I used to be a sysadmin and work with PowerShell a lot. That's pretty cool. I generally like it. It has more features that you would want. Dynamic arrays, hash tables, pipelines. Yeah, I know it definitely has more structured data, so being able to express some of that data is super nice. Like, super nice. I mean, that's why I reach for Rust, so I can have, like, a list of structured data, and then I can just kind of access them in a way that feels sane. It's nice. But Bash is just so much fun. Got to prove that you can do this stuff in Bash, you know what I mean? Oh yeah, that starting J is getting pretty high up there, which is nice to see. What was the problem one? 4867, I think. Because we're almost there. We're at 67. Once we get to 4867, we can kind of see what's going on. quite cool website. It seems you use the user agent to know the request is from curl. Absolutely. That's 100% how I do it. So if you change your user agent to be anything other than that, you'll get normal HTML. But if your user agent starts with lowercase c, URL, then I go ahead and give you the curl version of it. That's how I did it, or something like that. I documented it somewhere, but yeah, pretty much that. Oh, come on, this thing's so close to finishing. I'm just so ready for it to be done. Once that 9999 number starts moving, then it starts picking up speed. That's when it really starts picking up speed. All right, we're almost getting down to 4867. This is a riveting gameplay right here. This is such a good demonstration of what being a sysadmin is. When things are working but in a degraded state. So ideally things would either be working perfectly or completely broken, but usually you're in this gray area where it's like I'm sitting here like, looks like it's right. I'm just waiting for things to break. But what does it look like when it breaks? I have no idea. We haven't really defined that yet. So what am I waiting for? I don't know. I'm waiting for divine intervention to show up in my terminal and say, hey, here's the error right here and point to it. But that doesn't exist, so instead I have to sit here and figure it out, which is incredibly rewarding when you do, but incredibly frustrating in the process. So that's it. That's all I had to say. Nice, that left number's moving down now. So things should get a lot faster because we're actually making progress on the array. Cool, cool, cool. Yeah, so instead of 10,000, only like 3,000 to check right now, which is the difference between the left number and the right number. That's how I'm determining that. Wow. Wow. That got real fast at the end. I'm going to take the good checksum, and I'm going to put the good checksum here. That is the correct checksum, 62873, 62872. Look at that. It's still wrong. It's still wrong. How is it still wrong? Was it 4687? Was that the one that I was trying to move? Four, 8, 6, 7. Okay. Yeah, that looks right. All right, so now that we are done here and we got the wrong answer, we can do the same thing we did before. Because I don't think I actually... Did I write this out to a file? All right, I teed it to a file, didn't I? Final. Okay. So we can do a color diff final to rust done. So here is what we do. Oh, wow. Wow. We are so close to getting the answer, guys. Here is what we would have to do to make our bash version match our rust version. So bash thinks that 4867 exists, it has a size of 2, and there are 0 free spaces after it. Rust says that it exists, it has a size of 2, and there are 2 free spaces after it. That is the difference here. Bash thinks there are 0 free spaces after it, and Rust thinks there are 2. Boy. We are so close to the answer. Like, so close. It's unbelievable. I think we only need to recreate all the arrays if we move them. That's a speed up right there. Wow, that's crazy. That's crazy. The only difference is the free blocks that come after it. So the first thing we do is we increase the free. Oh. Yeah, let me think about this. I think in this example, F and C might be the same. Yeah, I think F and C are the same, but that's okay. Let me think about this. Because we escape the swap if it's next to the other and didn't update the size. Is there any other instances in the Rust version where free space is not 0 after remove? I don't know. Hold on. Let me think about this. I have to... I can't take in any other information until I understand this myself. We have C, we have G, and we have F. And in this case, F and F, which is the one that comes before G, is the same as C in this case. So F and C are the same. If that's the case, what do we need to do? So F becomes this. So we increment the free size of F to be everything that came after it. Yeah, this needs to only happen. This needs to only happen inside the swap. Like, it's crazy that that's the case, but that needs to happen only inside the swap. Else, don't swap them, just update free space. So in this scenario, we're not going to swap them. We are just going to update their free space. Can we come up with an example that triggers this behavior, maybe? Well, I already rewrote this logic. Actually, yeah. Let me do this. I have my idea, but let me do this. We're going to try and trigger this behavior. We'll do nothing in here. New example is what I call it. I need to get better at naming. Okay. Let me catch up. Do you ever use shell check? Yes, I'm a big fan of shell check. For these scripts, it's going to be a nightmare, so I wouldn't bother with it. But yes, I do love shell check. You can do vim-d, file 1, file 2. Oh, that's kind of cool. I didn't know that. I'll try that out. Because we escaped the swap if it's next to the other and didn't update. That's what I read before. Yeah, I think something going on here. Are you working on your Mac or your server? And does Mac have something like dtrace? Working on my Mac. Okay. Working on my Mac, and Mac does have dtrace. Apple ported dtrace over to Mac. And there's actually like a lot of providers on it, which is crazy. I'm not going to bother sudoing it. But yeah, there's a lot of providers on it, which is pretty cool. All right, 1.22. I can't have free space at the end of the example. Their inputs never have free space at the end. They're always an odd number. But I do have move new example to simple example. There we go. This will make my life easier. The simple example is literally 0, 0, dot, dot, 2, 2. Yeah. And it gets me the right answer. Can I get something that fails this example? What would fail it? If I constructed this scenario? Let me think about this. If we had... We would try to move the 222. If I had this example, we would try to move this to the left and it would fail because there's no room. Then we would move on here and try to move it to the left and it would succeed because there is room, but it wouldn't actually swap anything. I think we need that. So my simple example, I think we just change this to a 3. And we get 15. Now if we go into Rust and we cargo run -q, simple, we get 15. Okay, so the bash one works. Why does it work? I want the bash one to break. What can cause it to break? I need to create an example where it frees up space. Let me think about how to do this. One free block here. I think this might work. So we're going to try to move the 44. And it's going to fail. Then we're going to go here. We're going to try and move the 3. And it's going to work. And that's going to free up space for the 44 to go here. I think maybe this works. Two, 0, 1, 3, 4, 2, 0, 1, 1, 1, 1, 2. Whoa. Two, 0 free space. 1, 1, 1, 1, 2. $35. 47. Okay, so we're getting different answers here. Okay. Okay. So at the end of all that, what does the Rust one think? Yeah, the Rust one, there's some free space that's gone missing, which is the exact problem we were seeing before. So I think we've got the bash thing in a situation now where we can detect that situation. This isn't going to work, but it's going to do something. 49. And what does Rust say the thing was? 47. Yep, okay, so somehow it thinks there's still a free space of 1 and 1. That's fine. Don't swap them, just update the free space. So if they're next to each other, so if G was next to C, all of the free space that came after C should get set to 0, and we should add it to G's free space. That's all we need to do. So G's free space, free blocks at G, will get added to whatever free blocks at C was, and free blocks at C will get set to 0. I think that's how we do it. 47. That's the right answer. 2858. That's the right answer. I think that's it. I think that's it. I think that's it. Oh my God. Okay. So this should take another 15 minutes. Oh man. I'm gonna let this run. I'm gonna go grab something to drink, take a little break, maybe like 5 minutes or something. I'll be back. What's up, nerds? Is that a Ubiquity AP I see in the background? It is. Good eye. Where is it? Like here? Yep. I got the long range one. I have one in my garage as well. Delicious. This thing's still going. I mean, thank God it's still going, but... Delicious. Yo, what's up? What's going on? We are waiting for this bash one to finish. I am actually, for the first time, hopeful. I'm very hopeful that it will work. Nice, nice. Man, I hope this works. We've already been streaming for 2.5 hours. This puzzle has taken way too long. Oh yeah, you haven't been here. So yeah, a lot of stuff happened. After I streamed for 6 hours last night, I went, did some cardio, ate some food. Everything was good. About to go to bed. It was like 1 a.m. And I was like, screw it. I can't stop thinking about this. I need to do it. Busted out my laptop, banged out a Rust implementation in like 10 minutes. That's what I did. Then when I came on stream, I took up that Rust implementation, ran it against the data. It was wrong, but there were only a couple little off by one errors, and then I was able to get the correct answer. So using my Rust implementation, I got the right answer. Got the right answer. The algorithm worked exactly how I expected it to work. So now I'm just trying to go through and make the bash version work. So this is the bash version. It's going to take about 15 minutes to run. This is the Rust version. If you run the Rust version in release mode with the real input, you can see that I get the answer in 0.3 seconds. So the Rust one is way faster. But the bash one's working. Oop, now we're getting to the point where the bash one starts going way faster. So this is great. We're basically towards the end of this. So, yeah, making good progress. Oh, wow. Look at that. Even faster. What do we have here? That's a big number. I'm going to grab the correct number from the website, and we're going to paste it in. So as you can see, I grabbed the correct number there. I paste it in the terminal, and moment of truth. 62873, 62873, 17016, 17... Is right. It's right. It's right. We got it. Oh my god, we got it. The bash solution is finally correct. 2 streams, over 8 hours. Advent of Code 2024, Day 9, Part 2, in bash. Done. Done. We do fork out to one external tool, SEQ, for sequencing. I can do it in pure bash, but my god is it slow. So I just use that as a speed up. We're done. We're done. We debugged the shit out of that program now, sent it to oblivion. That's right. That's right. And it feels good. Oh, I put so much time and effort into this. Like, I'm so sick of it, but it feels good. Oh, man. Whew. I feel good. I feel good. I feel invigorated. I was almost choking my drink. Sorry. For the record, though, there are supposed to be solutions that work in less than 15 seconds, not less than 15 minutes. Don't worry, Aneurysm. That was just getting the bash solution to work, which I modeled after my Rust solution that I wrote when I got mad at bash. And my Rust solution can run in 370 milliseconds. So don't you worry. We can run it very fast. In fact, we're actually forking out to cargo. Let's not even do that. Target, release, Rust part 2, read in from, or give it real input. There we go. So if we fork it directly without even using cargo, look at that. 0.09 seconds, 0.08 seconds. So don't you worry. We got the Rust solution, and it is fast, and it is elegant, and it is beautiful. The bash solution sucks. I love bash, but it sucks. It sucks because it's very snappy. Here, I'll show you this aneurysm. You might like this. The Rust solution I came up with, I love it because it's so simple. It's like making a memory pager or a basic file system, which is so beautiful. You just have a struct. Every single block, I just made a file page struct. So we have the name of it. This was the original index before it's moved, which is nice. It's a U64. We can do work with it. We have the size. This is the size it takes up and how much free space it has to the right of it. So as long as each block keeps track of that, we can do whatever math we need. So our generating checksum logic, super simple. It looks like C code because I'm a C programmer, not a Rust programmer. And then, yeah, our main logic is here. So we have a while loop that I've named. We just do really basic stuff here. Ignore this. We were having trouble with block number 4867, so I had to figure out what was going on there. But yeah, now that we have room, I designed what it would look like. So we want to move G over to C, so it will now be in between C and D. I just defined what that algorithm looked like in human language and then wrote it out in code, and that was it. This was what was so hard, where I had to stop and be like, wait, let me just think of this like a human, and then write down what I want to do, and then just make the code do it. And that way I don't have to think about the code. It just works. And it just works, and it's so fast, and it's beautiful, and it's amazing. And I'm the best programmer that's ever lived. But no, seriously, I'm so happy that's done. Oh, my God. Oh, that was a mess. There was so much going on here. What do we even have? Part 2, day 6, nope, day 9 is working. There we go. Push that code up so we at least have that. And we are done, everyone. We are done. We are done with day 9. Let's go look at our beautiful puzzle. Look at that. Look at how beautiful this picture is becoming. Yeah, there are other stuff that we need to do. Okay, there might be 6 more puzzles that I have to do, but that's for a different time, okay? We're doing this nice and slow. But look at this. This is so cute. The picture's coming together. Thank you. Thank you for being proud. I appreciate that. Using bash to utilize CUDA to parallelize it. Yeah, I don't know about that. There might be a way to be multi-threaded, to be honest. There's probably a way to multi-thread it. It's difficult because you rely on the... When you create a new state, you rely on that existing state to figure out how to push things through. But I think there's micro optimizations we can do in so many different places. We can keep track of we kept track of the non-compacted areas. So once areas on the left got compacted, we started moving that pointer farther to the right. And once we got stuff on the right process, we started moving farther to the left. So we started getting closer to the middle. That was an optimization, which was good. We can do things by keeping track of like the largest free block available after a certain point. So like, hey, if you're looking for a thing that's 8 blocks free, we might not have it, but we can keep buckets. We could be like, oh, you want a 2 block free thing? Here's the first index of it. You want a 3 block free thing? Here's the index of it. Now you can start having metadata. I'm describing file systems. You can just start having metadata and metadata about the metadata that points to the nearest thing that you have to actually hop to. So yeah, without implementing our own file system, it's a little bit terse, but yeah, there are probably ways to do it. So yeah, we're done. Beautiful. Day 9 is done. It's complete. I'm going to call the stream here. I stopped unlisting my streams. I made them all publicly available, so they should be easier to find for people. Some people were complaining. So sorry if they pop up on your recommendations, but they should be available, and people can go watch them afterwards, which is nice. I will edit these and make these nice videos. Day 9 is going to be a mess to edit. I'm currently in the process of editing day 4. It's a slow process. But yes, thank you so much for tuning in, everyone. I'm going to call it here. I'll probably be back tomorrow, maybe, to do day 10. If I am, it'd probably be a little bit later in the day than it is right now. It's a little bit early. But yeah, we did it. You can rewatch this torture. Oh yeah, this video is going to be fun when I go through and edit it. We can split the input or the arrays, but if we somehow make it faster to find the spot of the 999, it would run under 10 minutes. Yeah, there's so many optimizations we can do. My brain's fried. Sorry, I didn't fully read your message and comprehend it. My brain's too fried to process new information. That's what's going on here. But I think we're done. I'm putting that in the books. I'm happy with how it works. I like that it popped up. Otherwise, I would not be here. Welcome. I'm glad you're here. All right. I'm calling it here, everyone. Have a good night. I will talk to you all later.